Hi, my name is Octavio, and today we're going to talk about a very common phenomenon that happens on Earth, which is the lightning. We're going to talk about some characteristics, how lightning is made, and some problems that are related with lightning. So let's get started. So, what is actually a lightning? A lightning is the occurrence of a natural electrical discharge of a very short duration and a very high voltage between a cloud and the ground, and sometimes it is going to be between a cloud and space within a cloud. A lightning is also going to be accompanied by a bright flash that we're going to discuss later on, and is going to be also typically accompanied by the thunder. Now, we have to make the difference between a thunder and the lightning. Now, the lightning is going to be the phenomenon that we're going to discuss that is related with voltage and current with electricity. Meanwhile, the thunder is just the phenomenon that we talk when we talk about the sound that the lightning creates. So they're not the same thing, and it's very important to know that. Now, how is a lightning made? How can we prepare the lightning? We have to first have a cloud. Mostly the clouds that create lightnings are called cumulonimbus or lightning clouds, and we're going to have clouds during a storm in most of the cases. Obviously, during a storm, the cloud has to have some water droplets are going to be necessary for the lightning to be created, and also some ice crystals are going to be created from the water droplets that are going to be inside our cloud. We're also going to be talking about airflow. We're going to talk about a cold airflow and a warm airflow that is going to affect the water droplets, the ice droplets, and also positive and negative charges that are going to be inside of the cloud. Now, how is the lightning made? We can say that the cloud is going to be our recipient. The cloud is going to have water droplets inside, all over the place. It's going to have water droplets like this. And also we're going to have our positive and negative charges. So let's see here, positive and negative charges all over the cloud. Now, we're going to talk about the airflows that are going to pass. The airflow is going to pass from the bottom side of the cloud, all the way to the top side. I said that we were going to talk about cold air flows and warm air flows. That's because the warm airflow is going to go up to the cloud and is going to attract all the positive charges with it. So the water droplets, the warm airflow, and the positive charges are going to go to the top of the cloud. Meanwhile, the cold airflow is going to attract all the negative charges, and some water droplets are going to become ice crystals because of the low temperatures that are going to be on the bottom side of the cloud. Now, as we can see in the image, and to see a an example of how can we relate a lightning with electricity is that we can actually see that with this phenomenon of the airflows and charges, we can compare our cloud as a battery or as a capacitor also. We're going to have positive charges on the top side, and we're going to have a negative charge into the bottom side. So it's a comparison that we can see between our knowledge about electricity with batteries and circuits and a natural phenomenon that is lightning. Now, there are 4 types of lightnings. As we talked before, lightning is the discharge between the charges of the cloud, between the charges of the ground, and in some cases, a space within the cloud. Now, as we saw before, we're going to have our negative charges on the bottom side of the cloud, and most of our positive charges are going to be on the top side. We're going to see that the ground is going to have also positive and in some cases negative charges. So the lightning is going to happen when all these negative charges create the discharge and attraction to the positive charges of the ground. At the start of the lightning, there is a forked form created that gives the lightning this form of a tree branch. We can also see that the negative charges are going to be attracted to the positive charges. This type of lightning, number 1, it is also very common because this type of lightning happens in 90% of the cases. 90% of the lightnings are going to be of this type, where a negative charge is going to be attracted to a positive charge. We're also going to have, like in case 3, something different. We're going to see that we have also our negative charges and positive charges in respective place on the cloud, but we're going to see that the lightning is going to be created from attraction of a positive charge. So we're going to have positive charges attracted to negative charges that are on the ground. This type of lightning tends to have a more higher voltage and current than this type of lightnings, but also we're going to talk about a 10% of frequency of this type of lightning. They're not very frequent. There are also some other types of lightnings. Lightning can be created not only from the cloud to the ground, but also from the ground to the cloud. That is the inverse direction than the 2 other cases. So we can have a positive charge on the ground attracted to a negative charge of the cloud. So the tree branch form is going to be created now on the upside and not on the bottom side. It's going to be created from the bottom to the top side. And well, as we have our positive to negative charges, we're going to have also our negative charges attracted to a positive charge. But in this case, the lightning is going to be also created from the ground and is going to be directed to the cloud. Now, there is another definition that we need to understand about lightnings, and that's the return stroke. The definition of a return stroke is the moment when negative charge and positive charges connect. Here in the drawing, we can see how the positive and negative charges are getting close together, and the moment when they all connect, we can see this white part. That's the return stroke, and actually, the return stroke is our main visible event. Is what we were talking before. The bright flash that happens on the lightning. That's what we will call a return stroke, and it's what we can see with the human eye. So in this diagram, we can see a 3 kilometers lightning. This is the moment when it's going to happen, the return stroke. All the negative charges are coming close to the positive charges in a step ladder form. Here is the return stroke, and here we have a dart ladder. That is the moment where the lightning will be over, or the moment where a second return stroke is going to happen. A lightning can have many return strokes, but approximately the average is of 4 or 3. So here's another example in other ways. Here we have 3 strokes of the same lightning. This is the moment where the discharge is going to happen on the tree branch form. And here's a time lapse between strokes, which is actually where the dart ladder is. Now, for example, let's see a lightning in slow motion. This is in slow motion, so we can actually see how the tree branch form is going to happen. This is the moment before the stroke, and we can see it because it's in slow motion. And this is actually the moment of the stroke, and this line is our dart ladder. That is when the lightning is going to stop. So this is in slow motion, so we can actually see all the phenomenon, but in reality we can only see the flash break, the bright flash of the lightning. So some of the characteristics of lightning. When we talk about current, we have 3 types of lightning. We have weak lightnings that have an average current of 2 kiloamperes. Medium-sized lightnings have approximately an average of 10 kiloamperes, and the strongest ones are approximately between 100 and 200 kiloamperes. That's actually pretty high current. The velocity, a lightning can go as high as 50,000 miles per second. The length of a lightning can go from 5 kilometers, sometimes 3, sometimes 6. It varies, and 1 centimeter wide. It also varies the length and width of the lightning. A lightning can discharge from 1 kilojoule to 10 kilojoules, and that's actually pretty much. And the temperature, it can actually reach 20,000 degrees Celsius. With all these measures, we can actually see why is a lightning so dangerous for a living being. And well, this is a small, another chart of sample size lightning that I took. The first strokes got 101 kiloamperes of current, so we can be talking about the strong lightning. The charge goes from 93 coulombs, the complete flash 94 coulombs, pretty the same of the first stroke, and subsequent strokes had a charge of 122. For example, we can talk about the duration of strokes and the interval between strokes. Here we can see it was 90 microseconds a stroke, the other is 150, and the interval between them was 133. which is pretty much the same as we saw in this last example. Um, can we actually determine where the lightning is going to strike? And the answer is actually no. Even though we know that by electric terms and stuff, the lightning is going to strike an object with less resistance and amplitude. Yeah, we can determine that if there is an object pretty high with a lower resistance, an object on the ground level, it's most commonly that it's going to strike the object that is high with less resistance. But actually, the activity of lightning is random, so we don't actually know what's going to happen with it. So when there's a storm, that's why people recommend to not be outside, because no one knows where is the lightning going to strike. Well, here are the references that I use. Some are some internet pages, some other are some investigation documents, some thesis about lightnings, and well, that'll be all from my part.